very warm welcome to each and everyone. Today in this class, we will be studying the subject Science and Technology of Class 9, Unit 16, Chapter Gases. So, gases. We are covered by sea of gases. That is, the Earth is entirely covered by atmosphere that contains many gases. And among all those gases, all those atmospheric gases, nitrogen is found in the highest amount, followed by oxygen. And in the other remaining 1%, hydrogen that we are going to study today in detail is only found in 0.000055% only. But so you must be wondering, if it is found in such a little amount, why are we studying it in detail? It is because hydrogen is abundantly found in many organic and inorganic compounds around us. Organic compounds such as carbohydrates, fats, proteins, in which hydrogen is found in huge amount. And in inorganic compounds such as water, which is very crucial for our survival, hydrogen is present. The molecular formula of water is H2O, in which you can see that there is 2 atoms of hydrogen combined with 1 atom of oxygen. That's why study of hydrogen is very important. Now let us introduce hydrogen. Hydrogen is an element which is represented by the symbol H. The atomic number of hydrogen is 1. So what is an atomic number? Atomic number is the number of proton contained in the nucleus of one atom of an element. In this figure, you can see that this is a single atom of hydrogen, and you can see that there is one proton present in the nucleus of one atom of hydrogen. That's why the atomic number of hydrogen is 1. Atomic weight. The atomic weight of hydrogen is also 1. So what is an atomic weight? Atomic weight is the sum of the number of proton and the neutron contained in the nucleus of one atom of an element. So from this figure you can see that hydrogen atom contains one proton in its nucleus and there is no neutron in its nucleus. So the sum of the proton and the neutron is 1 plus 0 is 1. That's why the atomic weight of hydrogen is also 1. The molecular weight. The molecular weight of hydrogen is 2. Now, since the atomic weight is 1, why is the molecular weight of hydrogen 2? It is because a single atom of hydrogen is unstable. So, it combines or it shares the outermost electron present in its outermost orbit with another hydrogen atom, forming a molecule H2. And due to this, molecular weight of hydrogen is 2. Why? Because molecular weight is the sum of the atomic weight of each atom present in the molecule. And there is 2 atoms of hydrogen present in the molecule. So, 1 plus 1 is 2. That's why the molecular weight of hydrogen is 2. And this 2 hydrogen atom is attached with each other by a single bond. Bond is the force with which atoms of the molecules are held together, and here you can see that 2 atoms of hydrogen is held by this force which is known as bond. Now not only hydrogen, many other elements are found in molecular state such as oxygen. 2 atoms of oxygen combines with each other to form a molecule O2, similarly Cl2, chlorine, nitrogen also form N2 and fluorine also form F2. Now valency. The valency of hydrogen is also 1. So what actually is valency? Valency is the combining capacity of an element with another element or radical. And since I mentioned earlier, hydrogen has single electron in its outermost orbit. That's why its combining capacity with another element or radical is 1. That's why the valency of hydrogen is also 1. Now, the density of hydrogen is 0.09 kg per meter cube, and it is the lightest element that is found in the entire universe. And the final thing is hydrogen has isotopes. So, isotopes are those elements that have the same atomic number but different atomic mass. Now, hydrogen has 3 isotopes: protium, deuterium, and tritium. Now from here you can see that atomic number, as I mentioned earlier, is the number of proton present in the nucleus of the single atom of an element. And from protium has one proton, deuterium also has one proton, and tritium also has one proton, which is represented by blue color here. So all of these three elements has single atomic number, that is 1, 1 and 1. Now atomic mass was the sum of the protons as well as neutrons contained in the nucleus of the single atom, and here neutron is represented by red color. Now in protium you can see that there is no neutron, so that's why its atomic mass is 1 plus 0, that is 1. In deuterium it has 1 neutron and 1 proton, that's why its atomic mass is 1 plus 1, that is 2. And in tritium it has 2 neutron and 1 proton, that's why its atomic mass is 2 plus 1 is 3. So that's why this has same atomic number but different atomic mass, hence protium, deuterium and tritium are the isotopes of hydrogen. Now let us study a little about the history of hydrogen. Chemist Henry Cavendish said that the hydrogen gas was a combustible gas in 1893, but that time he did not name this gas hydrogen. He just said that this gas is a combustible gas. Later on, Lavoisier named this combustible gas as hydrogen. Why? Because it gave water when it was combusted with oxygen. So the name hydrogen was given because hydro means water and gen means producer. So this combustible gas produced water when it was combusted with oxygen. That's why the name hydrogen was given. Now there are many methods that can be used to prepare hydrogen gas in the laboratory. So it might be confusing as to which method is preferred over the other. So there are 3 major points that you must keep in mind while choosing the perfect method. The first is the preparation method should be inexpensive, so it should not cost much. The other point is the rate of the reaction should be moderate, so that students like you guys can control the reaction and it is not dangerous for you. The last point is it should be simple to prepare, so you all students can easily prepare in the laboratory by yourself. Now for the laboratory preparation method, we will be using zinc metal and dilute hydrochloric acid. So we will be using zinc metal and dilute hydrochloric acid. So this is a displacement reaction. Why? Because the zinc metal will displace the hydrogen present in the acid, and what it will give is this zinc metal will displace the hydrogen and combine with chlorine. Now, the valency of zinc is 2 and the valency of chlorine is 1. So, after valency exchange, it becomes like this. Now, you should not write 1. So, it forms zinc chloride, ZnCl2, plus the hydrogen that is displaced. And I mentioned this earlier that single hydrogen atom is not stable. So it combines with another atom to form hydrogen molecule. So hydrogen gas is prepared. Now this reaction is not balanced. So we have to write 2 over here. So using this equation, now we will synthesize hydrogen gas in the laboratory. Now let us prepare hydrogen gas in the laboratory. For the laboratory preparation of hydrogen gas, as I mentioned earlier, we will be using zinc and dilute hydrochloric acid. So, the chemical required are zinc metal granules, which I have already poured some pieces over here, and hydrochloric acid, and I have already prepared dilute hydrochloric acid. Now, the apparatus required are wolf bottle. This is a wolf bottle which has 2 mouths. And we would also need a thistle funnel, and I've already attached a thistle funnel in the wolf's bottle through a cork. We would also need a delivery tube. First of all, delivery tube is like this, and I've already bended this delivery tube according to the need for the preparation of this gas. And I've also attached the delivery tube with the wolf bottle. Then we would need a beehive shelf, a gas jar, and a water trough that is filled with water. Now let us set the apparatus for the laboratory preparation of hydrogen gas. First of all, we should put the zinc metal into the wolf bottle. Now the first precaution we should take is we should make the wolf bottle airtight. So for this, I will seal all these crevices using the candle wax. After we have sealed the wolf bottle, let us set the delivery tube into the water trough, beehive shelf. Now we won't place the gas jar right now, because when we synthesize the hydrogen gas, first of all the air present in it will get mixed up with it. So we will let some of the hydrogen gas pass out, then only after some time we will start collecting the gas, because after some time only we will get the pure hydrogen gas. Now let us fill the gas jar with water. The gas jar should be completely filled with water, because if it is incompletely filled, the gas collected will be mixed with air and the obtained hydrogen gas will not be pure. So let's keep this aside. Now to this zinc granule, we will add dilute hydrochloric acid through the thistle funnel. We should make sure that the tip of the thistle funnel is entirely dipped in the hydrochloric acid, because the gas should not escape from the thistle funnel. But the tip of the delivery tube should not be dipped into the acid, because if the tip of the delivery tube is dipped, then what will happen is hydrogen gas will not be able to pass through the delivery tube. So that's why the tip of the delivery tube should not be dipped, but the tip of the thistle funnel should be entirely dipped. Now you can see that the reaction has already started, but we will not collect this gas as of now, because we will wait for all the air to pass through, then we will collect the pure hydrogen gas. Now here you can see the air bubbles, which mean the gas has started to come out from the wolf bottle through the delivery tube. Now we will place the gas jar and collect the hydrogen gas. We should dip the gas jar entirely, then only remove the cover slip. Now you can see that the hydrogen gas is getting collected in the gas jar. Now you can see that the gas jar is completely empty, so hydrogen gas has already been prepared. So to confirm that this produced gas or the synthesized gas is hydrogen gas, we will do the confirmation test. So now you can see when you place, you can hear this pop sound. So hydrogen gas is successfully prepared in the laboratory. Now you saw that we have prepared hydrogen gas in the laboratory, and we have already confirmed that the synthesized gas was hydrogen. When we placed the burning flame close to the gas jar, we could hear the pop sound. So that suggests that the gas we synthesized was hydrogen gas. Now let us continue our class and study about some precautions that we took while doing experiment in the laboratory, and study about some physical and chemical properties of hydrogen. So now we synthesized hydrogen gas using this displacement reaction, that is using zinc and dilute hydrochloric acid. Now let us revise all the precautions that we took while we prepared hydrogen gas in the lab. The first precaution we took was the apparatus should be washed well. That is, all the apparatus that we will be using or we already used previously should be washed well. The second point is impure zinc should be used. So why impure zinc is needed? Because the impurity that is present in the zinc acts as a positive catalyst. So since it is a positive catalyst, it increases the speed of reaction. That's why impure zinc should be used. And since you saw that I was using candle wax to seal all the crevices present in the wolf's bottle. So why did I do that? So that no hydrogen gas that we prepared would escape from it. So why did I do that? So that the apparatus will be air sealed. So the third precaution is apparatus should be airtight. Now the fourth precaution that we should use is dilute hydrochloric acid. So why dilute hydrochloric acid is needed is because if we use concentrated hydrochloric acid, it is highly volatile. So the fumes of the acid will get mixed with the hydrogen gas that we prepared. So the prepared hydrogen gas will be impure. That's why dilute hydrochloric acid should be used, but not concentrated hydrochloric acid. Another precaution that we must remember is the tip of the thistle funnel should be dipped entirely into the acid and metal mixture. Why? So that the gas will not escape from the tip of the thistle funnel but gets collected there. And the another point is the delivery tube should not be dipped in the acid and the metal mixture. Why? Because the produced gas should be able to travel through the delivery tube and reach the gas container. That is the gas jar where we will be collecting the hydrogen gas. So we should remember that the tip of the thistle funnel should be dipped, but the tip of the delivery tube should not be dipped. If we dip the tip of the delivery tube into it, what will happen? The produced air will have no place to escape because we have already sealed the apparatus airtight. So the wolf's bottle might even burst. That's why we should be very careful about this point. Now the final point you should remember is the gas jar should be completely filled with water. If it is incompletely filled, the incomplete space will be covered with air. And what will happen is the hydrogen gas we synthesized will get mixed up with that air. So the prepared hydrogen gas will be impure as it will also contain gases that is present in the air. So the gas jar should also be completely filled with water. Now let us study a little about the physical properties of hydrogen. Now when we synthesized hydrogen just now in the lab, you saw that hydrogen gas did not have any color. So hydrogen gas is colorless. It does not have any smell. So it is odorless and it has no taste. That is, it is tasteless. So the first physical property of hydrogen is colorless, odorless and tasteless. Now the another physical property is hydrogen gas is lighter than air. That's why when we were kids, the hydrogen balloon that we used to buy, we used to hold it tightly with our hand through a thread, or we used to tie it around our wrist so that it won't fly up in the sky. So why would hydrogen balloon fly up? Because hydrogen gas is lighter than air. That's why it used to fly up. So another physical property is hydrogen gas is lighter than air. Now the another physical property is hydrogen gas does not dissolve in water. That's why it forms air bubbles after it comes out of the delivery tube, and when it is being collected in the gas jar, it forms bubbles and it rises up because it does not dissolve in water. Now there is one important question that you all should know about. It is, how is hydrogen collected by downward displacement of water? Now this is possible due to two major physical properties. That is, it is lighter than water. Since hydrogen is lighter than water, it rises up and gets collected over here, and when it gets collected, it displaces the water downwards. And the second physical property is it does not dissolve in water. That's why it forms bubbles and it rises up. So since it is lighter than water and it does not dissolve in water, hydrogen can be collected by the downward displacement of water. Now, another physical property is hydrogen does not respond to litmus paper, be it red or blue. It does not change the color of the litmus paper. So we can say that hydrogen is a neutral gas. The final physical property is hydrogen gas can be changed from gaseous state to liquid state at the temperature of minus 253 degrees centigrade, and it can be changed into a solid state at the temperature of minus 259 degrees centigrade. These are all the physical properties of hydrogen that I just explained it to you. Now let us look at some chemical properties of hydrogen. Now, this first chemical property of hydrogen is due to the reason that it forms water when it reacts with oxygen. That's why it was also given the name hydrogen by Lavoisier. So when hydrogen is reacted with oxygen, it gives us water molecules. Now the another chemical property is hydrogen gas reacts with non-metals such as carbon at high temperature. So what happens is, when carbon reacts with hydrogen, it gives methane. Similarly, when hydrogen also reacts with another non-metals like sulfur, it gives us hydrogen sulfide. Now the another chemical property is hydrogen gas reacts with less reactive metals like sodium, potassium, calcium, and it gives us unstable metallic hydrides. So sodium reacts with hydrogen, or hydrogen reacts with sodium to give us sodium hydride. Similarly, hydrogen reacts with potassium to give us potassium hydride, and hydrogen also reacts with calcium to give calcium hydride. Now the other chemical property is when the oxide of less reactive metals like copper oxide or lead oxide are heated at a very high temperature, and when hydrogen gas is passed over it, then the hydrogen gas reduces the metallic oxide into metal. So let us understand this through a figure. So here you can see when metal oxide is heated at a high temperature and hydrogen gas is passed over it, then what happens is the hydrogen gas reduces this metal oxide, that is, it reacts with oxygen present in this metal oxide and forms water molecule, and it gives us pure metal. So this process is also known as reduction reaction. Why? Because a reduction reaction is a chemical reaction in which either the oxygen is removed or the hydrogen is added to an element, a molecule, or a compound. So here in this process, metallic oxides such as copper oxide in copper oxide or lead oxide, when it is heated at a high temperature and hydrogen is passed over it, it reacts with the oxygen present in the oxide. So it takes away the oxygen. So that's why it is a reduction reaction. So it takes away the oxygen, forms a water molecule, and gives us a pure metal. Similarly, in lead oxide, hydrogen reacts with oxygen and gives us pure lead. So that's why this is known as reduction reaction. So this is the reducing property of hydrogen. Now, after we have studied about all those physical and chemical properties, let us see the uses of hydrogen. The first uses of hydrogen that I just mentioned is hydrogen is used to obtain metal from metallic oxide. The another use is when hydrogen reacts with nitrogen by Haber's process, we can obtain ammonia. And this Haber's process, you will be learning it in detail next year in class 10. The another property is hydrogen is also used to convert the vegetable oil into vegetable ghee. And the process of converting vegetable oil into vegetable ghee is known as hydrogenation. Liquid hydrogen is also used as fuel in rocket, and when that hydrogen reacts with oxygen, it produces tremendous amount of energy, and that energy helps the rocket to propel up from the surface and gets launched out into the space. So hydrogen is also used as fuel in rockets. Now the final use of hydrogen is when hydrogen burns with oxygen, it gives us oxyhydrogen flame that you can see in the video here. And this flame is used to either cut the metal or weld the metals together. So the final use is when oxygen is burnt with hydrogen, it gives us oxyhydrogen flame that is used in cutting and welding metals. So these are all the uses that I just explained to you now. Now, since we have studied so much about hydrogen, let us check ourselves by trying to solve this one MCQ. So this is a statement. Pure zinc pieces and dilute hydrochloric acid are used in laboratory preparation of hydrogen. Argument 1 is, in this process, one of the byproduct of the reaction is zinc chloride. The second argument is, hydrogen is lighter and is soluble in water. So it is collected by downward displacement of water. Now we have to see which of these 4 points is correct. Now let us look at the statement. Pure zinc pieces and dilute hydrochloric acid are used in laboratory preparation of hydrogen. Is this true? No, it is not. Why? Because I just told you that impure zinc pieces should be used because that impurity acts as a positive catalyst and it speeds up the rate of reaction, and dilute hydrochloric acid is used. So the statement is incorrect because impure zinc pieces and dilute hydrochloric acid are used in the laboratory preparation of hydrogen. Now let us check if argument 1 is correct or not. In this process, one of the byproduct of the reaction is zinc chloride. Now this was the reaction that we used to prepare the hydrogen gas in the lab. So here you can see that hydrogen gas is produced when zinc reacts with hydrochloric acid, and the byproduct is zinc chloride. So argument 1 is correct. Now argument 2. Hydrogen is lighter and soluble in water, so it is collected by downward displacement of water. Now let us look at this in detail. So I mentioned this earlier, there are 2 major properties due to which hydrogen can be collected by downward displacement of water. The first one was it should be lighter than water, and the second is it should not dissolve in water. So these are the 2 properties, and hydrogen has these 2 properties. So it is lighter than water, and in the argument it states that it is lighter than water. So it is right. But in the argument 2 it says that it is soluble in water. But hydrogen is not soluble in water. That's why it forms bubble as it transfers to water and it gets collected upwards. So this argument 2 is not entirely correct. So it is incorrect. So hydrogen is lighter and insoluble in water. So it is collected by downward displacement of water. So we can say that argument 2 is incorrect. So statement is also incorrect. Argument 2 is also incorrect. So option 2 is the correct answer. So I hope you guys understood everything about hydrogen that I taught, and hope you'll also try to synthesize this gas in your laboratory if possible. Now I'll see you guys in the next class.